All right. Good morning, everybody. Welcome to the Compliance Assurance 101 training by Region 5 EPA. My name is A.H. Hasabala. I'm with the Air Permitting section, and today I'll be one of two of your instructors for this training webinar. I am in good company, and I will let my colleague introduce themselves.
Thanks, Hasabala. Once again, good morning, everyone. My name is Brian Blanchard, also here, US EPA Region 5 Air Permit section, where I primarily work with the Michigan Air Permitting Program.
Thank you, Brian. Brian, as I start, would you continue letting people in, and I'll focus on the slide deck to start?
Sure thing.
Thank you, sir. Okay, a few housekeeping items. For this training webinar, the audience target is new staff and permit writers. However, it could be also be a good refresher for more experienced folks. Your attendance and presence is welcomed and appreciated. This is an online meeting or a training webinar. It is recorded. A kind reminder to please keep your mics off and your cameras off. The recording of the training will be shared subsequently after the training. Please stay tuned for a follow-up email. Throughout the training, we do encourage participation. Please feel free to use the reaction button if you see something you like. We can certainly entertain questions. Just raise your hand or let us know. We can also have a Q&A discussion at the end of the presentation. Just keep track of the slide number or jot down your question, and so we can refer back to it. At the end of the presentation, we will also share a survey link, and this would be your opportunity to tell us how we did, give us feedback. We've also shared a pre-training self-assessment test that was voluntary, and this was mainly used to guide the discussion we will have together, and there will be more on that in a bit. All righty. A few disclaimers to start us off. This training seminar summarizes regulations and policy on compliance assurance monitoring and other Clean Air Act programs, such as the Title V operating permits. Let's see, the training does not create any new policies or interpretations, and the cited provisions and regulations speak for themselves. The training does not intend to communicate more than what is expressed in the reference. Therefore, one should use their own assessment of the provisions as per the particular case of their interest. And just a reminder that federal regulations may differ from tribal, state, and local rules with approved Clean Air Act programs. For today, the learning objective of the training is to introduce the core concepts of compliance assurance monitoring and the relevant regulations under 40 CFR 64. We also see how they fit with the Title V operating permit program. And upon completion of this webinar, the hope is that we all achieve a better understanding the role CAM has to play, its applicability, and where and how to actually implement it. Now, how well you may relate to these goals may be influenced by or depend on how you feel or did in the previously shared self-assessment. Speaking of which, about a month ago, we shared the voluntary self-assessment pre-training knowledge-based test. And the idea was to gather insights that can guide the discussion and point us towards particular points that may be worth a little bit more attention. Generally speaking, somewhat of a wide standard deviation. However, the median and mean seem to be relatively close. So that's a good sign, around 79 and 80%. There were a few questions that seemed to be a little bit more challenging, particularly in regards to the when the triggering of part 64 or CAM. And also another one that was worth a few extra minutes are what the particular emission unit and its subjectability or its applicability under 64. So we will definitely touch on those as well. All right. Are there any questions thus far? We're good? Sounds good. Seeing thumbs up. Love it. All right. Now that that's over, our agenda for today is relatively simple. We will be sharing background on CAM, see where it applies, how to actually apply and implement it, and then we'll conclude the training with one or two examples as miniature case studies, if you will. And at this point, I will turn it to my colleague, Brian, who will take us over the first leg. Brian?
All right, thanks, Hasabala. So let's get right into it, shall we? Why is the CAM rule important? Well, to start off with, the EPA establishes the emission standards to protect public health and the environment, where certain emission units require additional control devices installed to meet these standards set. As such, the CAM rule requires certain sources to monitor the operation and maintenance of these control equipment so that they can evaluate the performance of the controls and report back whether their facilities meet established emission standards or not. And finally, if sources find that their control equipment is not working properly or meeting these emission standards, the CAM rule requires timely action to correct any malfunctions and to report such instances to the appropriate enforcement agency. Moving along a little bit more on the CAM background with some dates, we got that the CAM approach was intended to originally address the requirement in Title VII of the 1990 Clean Air Act amendments, also known as the enforcement provisions, where EPA promulgated enhanced monitoring and compliance certification requirements for major sources. And this is related to the Title V requirements with regards to monitoring, reporting, and record keeping. The agency, as always, recognizes that ongoing compliance is a two-step process. First, that the control measures are installed and operated and proven to meet the applicable requirements set. And two, to ensure that the source continues to meet applicable requirements once these control measures are installed. And these final rule revisions for CAM were promulgated in October 22nd, 1997. There's a Federal Register link there and officially codified under 40 CFR Part 64. A little bit of connect between CAM and Title V permitting. Title V monitoring requirements are listed on their 70.6 A3I and 71.6 A3I as well, depending on who the permitting authority there is. And the CAM's focus is on specifically emission units with these add-on control devices. A little brief summary of what a control device is it's equipment other than inherent process equipment that is used to destroy or remove air pollutants prior to discharge to the atmosphere. And that's found under 40 CFR 64.1. And when operating control devices within acceptable ranges, as they were designed to operate, it should minimize emissions and provide reasonable assurance that the facility is complying with its permit terms and conditions. And the CAM rule streamlines these monitoring requirements, so only the important elements are included in the Title V permit. This includes Title V compliance certification language that allows the source owner or operator to use compliance assurance monitoring data to establish their compliance status with their permit terms or conditions. So that was a little bit of a background. Let's jump into some applicability. So generally, you have 4 applicability criteria for CAM. First one being that it applies to a non-exempt pollutant-specific emission unit and a major source requiring a Title V permit. Second, we have that the unit is subject to emission limits or standards not specifically exempt. And third, the unit utilizes a control device to achieve compliance with the emission limits. And fourth, the unit's potential pre-control emissions are greater than or equal to the major source emission threshold in tons per year. And all 4 of these need to be satisfied before CAM can be applicable. So here's a little hypothetical example just to get started. We have 2 emission units. We have a hammer mill shredder and a steam boiler. The hammer mill shredder has 2 pollutants, VOC, PM10. The boiler has 4, NOx, SO2, CO, and PM10 as well. So looking at this from a basic CAM standpoint, the hammer mill shredder is divided into 2 pollutant-specific emission units. One is the VOC, and the second is the PM10. So first we have to look at VOC. Are the pre-control emissions above a major source threshold? No. Does it have a control device? No as well. So that emission unit, or that pollutant-specific emission unit for VOC, will not have CAM applicable. Looking at PM10, however, we see that their pre-control emissions are greater than the threshold at 220 tons per year, and they use a control device on that emission unit to limit their PM10 to 2 pounds per hour. So assuming there are no exemptions or any exemptions there, the PM10 pollutant for that hammer mill shredder does have CAM applicable to it. Looking at the steam boiler, we can see for the NOx, first and foremost, it does have greater than a major source threshold at 300 tons per year. It is using a control device, a thermal oxidizer in this case, so CAM would potentially be applicable. The SO2 does not have the emissions greater than the major source threshold at 90, even though it does use a control device, so CAM would not be applicable here. The carbon monoxide, we do see that the emissions are greater at 249 tons per year, but they don't use the control device, so CAM would not be applicable here. In PM10, we see that while they do have a control with the cyclone, the pre-control emissions are lower than the major source threshold, so CAM would not be applicable. Moving on, let's just add an extra column so you can see where CAM would potentially be applicable there for the PM10 and the hammer mill shredder, and the NOx for the steam boiler. And with that, I will hand it off back to Hasabala to go through the applicability flowchart.
All right, thank you, Brian. Before I get started, I see a few questions in the chat. A question from Carrie regarding pollutant-specific emission units and their grouping. We will get if you be patient for a slide or two, we will get to that. And if we don't address it, please ask the question again. Okay. Thank you. Okay, so we jumped early on into a big example to get our feet wet and prepare us to break down the applicability of CAM. So what does this contextually look like? To interpret applicability in a more practical manner, we created this flowchart to facilitate the process. Now, this is a big slide, but do not worry. We will be spending some time on it, and we will dissect it thoroughly together. But briefly, it breaks down the previously mentioned 4 requirements step by step to determine CAM applicability. And it generally flows in a clockwise direction where every step is sort of a gate or an adventure where if you pass it, you can move on to the next stage until you ultimately reach CAM applicability. However, if at any point you fail to pass that stage or pass that gate, you're automatically not required or not subject to CAM. And in the middle, there are exemption criteria that can also nullify CAM applicability. And we'll get into each of those stages, if you will, together. Okay, first up is your starting point or launching pad, but it's a description of what CAM is, and CAM is intended to provide a reasonable assurance of compliance with applicable requirements under the Clean Air Act for large emission units that rely on pollution control device equipment to achieve compliance. First, what is an emission unit? And that is in part 64.1, it states that an emission unit has the same meaning as 40 CFR 70.2, which in turn says an emission unit is any part or activity of a stationary source that emits or has the potential to emit any regulated air pollutant or any pollutant listed under 112B of the Act. Quick sidebar, this term is not meant to alter or affect the definition of the term unit in Title 4 of the Act. But digging further within this definition of emission unit, we have a regulated air pollutant. Once again, this is a regulated air pollutant has the same meaning provided under 40 CFR Part 70 or 71, and those include your NOx, your VOCs, these are your benzenes, your glycols, and so on. It also includes the criteria pollutants with National Ambient Air Quality Standards, your NAQS, any pollutant from section 111, 112, your HAPs, class 1 or 2 substances. These are your stratospheric ozone protection chemicals, your chlorofluorocarbons, and so on. And then last but not least, your surrogates, which use one pollutant to infer emissions of another pollutant, and you can think of like NO2 or VOC for ozone. Now, a common question we tend to get here is whether an otherwise non-regulated pollutant that is being used as a surrogate for a regulated pollutant would apply for this purpose. And the short answer is yes, it applies. According to 40 CFR 64.2A1, the unit is subject to an emission limitation or standard for the applicable regulated air pollutant or a surrogate thereof. All right. Thank you, Brian. You're addressing the questions in the chat. That's great. Okay. In the spirit of questions, let's do a quick pop quiz where we get to ask you a question, and let's see how well this works. Bear with me. In your chat box, the question should appear. But the pop quiz question is, which of the following pollutants are regulated under CAM? Please select all that apply. You can use your chat feature to please select your answer. All right, great. Where responses are coming in. Glad it's working. Wonderful. There is still answers coming in. All right. Well, maybe another minute or so if you're still wanting to participate. All right. It seems like we have a consensus. Should we continue, Brian?
I think we can.
All right. So there is some chat, but we'll talk about it. It seems most are coalescing around B, C, and D, your criteria pollutants or regulated air pollutants. And yes, option A and option E, where we're talking about carbon dioxides and PM as total suspended particulates, there's a little bit of, it's a little bit tricky. Let's start with A. So VOCs in general include any compound of carbon, but excludes CO2. Now for CO2, there has been in the 1990 amendment has included provisions for that particular pollutant. However, they are actions relating to research and reporting, but not actually emission control. And therefore, EPA recognizes that it's not a regulated air pollutant. Now, for PM as total suspended particulates, it's also another tricky part. But in the early 90s, PM was a regulated air pollutant. However, in the mid 90s, EPA reevaluated its position and holds that PM 2.5 and PM 10 are regulated pollutants. However, not PM as a total suspended particulates. And there are links that as citation sources in the presentation, but basically these memos get into the explanation of why the answers are B, C, and D, and so on. And I won't open these memos, but the links are there for you. And to summarize what the memos say, the gist is the fact that the PM emission limits are included in the NSPS as surrogates for PM10. That doesn't make PM as a regulated air pollutant under the CAM definitions. And for the purposes of CAM, and this is based off 64 and 70, PM is not a regulated air pollutant. Yes, Gina, this presentation will be shared, and there will be a recording. And I see most of the chat are the answers. So, sounds good. Okay. moving along. Now that we have a kind of like an overarching view of what CAM is, we can move on to the next step of our adventure, and that is the next stage, which basically says, is the emission unit a pollutant-specific major source requiring a Part 70 or a Part 71 permit? Now, the definition of a pollutant-specific emission unit is an emission unit considered separately with respect to each regulated air pollutant. So you can have one emission unit that releases criteria pollutant A and a criteria pollutant B. So it would be considered separately. The CAM rule is based on pollutant-specific emission unit. A common question here that one of our colleagues may have alluded to earlier is can or should we aggregate related individual processes into one emission unit, or how to apply CAM to multiple emission units or activities that may be subject to a single emission limit and bent to a common control device. And an example here is you have a number of polluted specific emission units, say a series of 4 coding lines or so, and they're collectively controlled by a control device. What would you do in such a case? And the answer is that the potential free control emissions would be calculated for each pollutant-specific emission unit. And if those emissions are less than the major source threshold, then the coding line would not be subject to CAM for that pollutant. The second part here is that it is a major source. What is a major source? This would have the same definition as Part 70. Now remember, this is in the context of operating permits. Nonetheless, the major source threshold could still be something different than 100 tons per year. For example, the major sources under section 112, the threshold would be greater than 10 tons per year for a single hazardous air pollutant, or 25 tons per year for a combination. It's important to note as well that sometimes fugitive emissions would need to be accounted for if the source is a listed category, and these are basically your heavy big polluters, your coal plants, your coke oven batteries, refineries, and so on. But just a friendly reminder, quick reminder, fugitive emissions are those emissions you cannot reasonably pass through a hole, a stack, or a chimney. They're emissions that escape capture. All right, we'll take a quick pause. There seems to be a few questions. Hey, Carrie, do you have your hand raised?
The group of emission units with the common control. So even if the emission limit applies to that group of emission units, not the individual units themselves, you still wouldn't calculate pre-control emissions based on the group, since the purpose of CAM is to ensure that the control equipment is operating properly to meet the emission limit.
Right. So if you would consider it for each. You have to define the emission unit. If the limit is on a specific emission unit, so if that emission unit is less than the major source threshold, then it's not subject. You would consider it for each emission unit.
But if the limit applies to a group, say it's a ton per year limit of VOCs for all of the 10 coding lines combined.
Right. So each of those coding lines have that emission unit. Or are you suggesting the total of the coding lines have one emission unit?
They have one emission limit. So
emission limit, sorry, yeah.
Yeah. Since they have one emission limit, they need it applies to that group of equipment. So the purpose of CAM is to ensure that the control device is working properly to meet the limit. And that's right. All the limit applies to all of them combined. So I don't understand why the pre-control would only be based on one when the limit applies to all of the units combined.
Right. I believe that the emission limit applies to an emission unit, and whether or not this emission unit is part of a series of other emission units subject or controlled by one control device, you would consider each emission unit separately. Now, if the emission limit is on a collection of emission units, then you would have to interpret it accordingly. If you define the lines, the 10 lines as a single emission unit, then it is a single emission unit. But as far as CAM applicability goes, the limits are on a single emission unit, and you would consider each individually. And if that emission unit has an emission limit and has emissions less than the major source threshold, then it's not. If it's greater, then it is subject to CAM.
Okay, thanks.
Thank you. I'm just reading, I'm trying to catch up with the questions in the chat, making sure the CAM does not apply if you cannot separate the group into single emission units, correct? This is, I'm not sure that's a CAM applicability. That's not how CAM is applied or not applied. Okay. Moving along. Okay, this brings us to the next stage. Now that we have a pollutant-specific emission unit for a major source requiring a operating permit, we reach a stage where we can have examples. These exemptions. These exemptions, they can nullify the CAM applicability. The orange box lists a summary of those exemptions in somewhat of an order of not priority per se, but commonality, let's say. And just like on the top of the list, municipally owned units for the purposes of electric generation are exempt. Section 111 and 112 standards post November 1990 are exempt. And regarding those specific sections, Section 111 and 112 standards post November 1990, there is a caveat regarding the acceptability of the rules that were amended post November 1990. in the tables for the NSPS NESHAP section, they do include standards proposed after November 1990. However, they do not include rules that were amended after November 1990. Now, whether an emission standard that was amended after November 1990 are exempt from CAM or not would depend on the very nature of the amendment in question, and whether the amendment material includes monitoring requirements that satisfy CAM. Now, this is somewhat of a rare case. There may be one or two of such rules that have been identified, but the commonality here is that the added provisions that were amended include testing, monitoring, and record keeping and reporting requirements of the alternative control, and therefore making it satisfactory for CAM. And the emission unit in that particular case that is subject to the amendment would be exempt from CAM. Okay. This next slide is a blow up of the major or common exemptions. In addition to the first two, we have other exemptions that apply to the acid rain program, your Title IV, your stratospheric ozone protection, and limits that already have continuous complying determination methods. Those are exempt. Now, maybe worthwhile to mention that there has been a 1997 ruling from a Coventa Title V order, and that's out of Pennsylvania. But some common, like the common misconception was that the post November 1990 NSPS NESHAP exemptions does not apply to state emission limits or standards under Section 112 of the Act. And that's basically a reference to the disclaimer we shared at the top of the slide deck, is that federal regulations may differ or be different from local, state, or tribal regulations. And just to reiterate, this is already addressed, but amendments after November 1990 are not necessarily addressed. You would need to ask if the updated standard addresses monitoring in such a way that it would satisfy CAM requirements. All right, I'll take a pause before we move on and catch up with the chat. Why is CAM exempt? Oh, thank you, Brian. All right. Irana, do you have a hand raised?
Yes. My question is why the municipal entities have been given a special privilege?
Oh, well, we'll have to go back to Congress. This is our regulations. I don't know why it says so. They are a special entity. They are, yeah. The short answer is that it's under 40 CFR 64.2.
Yeah. We have the similar situation in Michigan. They do not have to pay the full fees, Title V fees, if they are municipal entities. So there is somehow some favoritism towards municipal entities.
It may seem so, yes. Okay, we can continue moving on. We have another pop quiz question that I will release into the chat momentarily. Give me a second, please. All right, question 2, pop quiz question 2. Consider multiple emission units performing the same task under a specific operation and venting to a single control device. Select the correct applicability approach. I believe we may have had a discussion a few slides back on this particular case, but doesn't hurt to go over it one more time. All right, it seems like answers are rolling in. Maybe take a minute or two if you wish to participate into the pop quiz. Use the poll feature to select your answer. Brian, do you think we can move along?
I think should be good. Maybe a couple more seconds.
All right, a couple more seconds it is. Based on the polling percentage, seems most of us benefited from this prior discussion. Okay, the answer is C. If the potential pre-control emissions for a single emission unit, as you define the emission unit, as the emission unit is defined, are greater than the major source threshold, then CAM is applicable. And we're probably going to sound like a broken record here, but bear with us. The CAM rule is based on a pollutant-specific emission unit. Potential pre-control emissions would be calculated for each pollutant-specific emission unit. And if those emissions are less than the major source threshold, then that emission unit is not subject to CAM for that pollutant. It may be very likely that the emission unit would be subject to CAM for another pollutant. Okay, moving along into our flowchart adventure. Now that we're a pollutant-specific emission unit, we are required a permit, and there aren't any exemptions that would nullify CAM applicability. We can move on to the next stage, which is, are control devices used to achieve compliance? Compliance with what? That is to say, is the emission unit subject to an emission limit or standard and uses a control device to achieve compliance? What is an emission limit or standard? It is any applicable requirement that constitutes an emission limitation, emission standard, standard of performance, or means of emission limitation as defined under the Act. Now note that limit or standard can be expressed as a specific quantity of pollutant. That is basically like tons per year, or a rate concentration, let's say pounds per hour, or some sort of amount per your fuel consumption. And as a relationship of controlled versus uncontrolled emissions. These are your percent captures, your percent destructions, and of course, there is an embedded daisy chain definition within that definition, but basically it is any applicable requirement, and that's defined in 70.2, but you can think of those as your terms and conditions in your construction permits, your standard requirements under the different sections or parts of the Act. So those are the definition you use to interpret an emission limit or standard in the context of applicable requirement. We, early in the presentation, touched upon this, but it's a part worth visiting again. And here, it's the second part is the control device, which, as previously defined, is an equipment used to destroy or remove air pollutants prior to the atmospheric discharge. These are neither inherent process equipment nor passive control equipment. It's likely that most of us are familiar with what control devices are, but those are your fabric filters, your carbon heads, condensers, and so on. Now, inherent process equipment, they're defined in 64.1, but basically they are equipment that are integral to the process in question. And we will get into a comparison chart in the next slide. And on the other hand, a passive control device, which also prevents the release of pollutants, but it does so passively as opposed to actively. And you can think of your seals, your lids, your roofs, and your choice of low polluting fuel or feedstock. Those are passive control devices. So passive control devices and inherent process equipment are not control devices. Okay, this slide puts it side-by-side comparison of control devices and inherent process equipment. We just defined control devices in the previous slide, and the point worth stressing here is that the CAM rule requires or is based on the use of a control device. The tricky part is that some equipment may seem to meet the definition of control device, but they're actually not. And the classic example here is a fabric filter on a pneumatic conveyance system. Sometimes its purpose is material recovery or segregate product on a particular size distribution, and this makes it inherent to the process function. Other times, they would be added as additional equipment installed to directly control air pollutant before they are released to the atmosphere, and therefore they ensure compliance with a particular air pollution regulation. And generally, this would this kind of interpretation would be a case-by-case assessment, and you would have to consider, and it might be helpful to consider if an applicable requirement explicitly states anything about related control devices and what exactly they may consist of, and accordingly assess whether it can even be an inherent control device or not. Now, on the other side of that, you have the inherent process equipment. And just to reiterate, this is equipment that are integral to the process in question. They provide some sort of function or safety measures that are inherent to the process. Now, an important point here is that if the inherent process equipment operate at an efficiency higher than normal to achieve during normal operations to comply with an applicable emission limit, then it no longer meets the definition of inherent process equipment. So if you have an inherent process equipment and it operates at a certain efficiency under normal conditions for material recovery or whatever, but then you would have to increase its efficiency or operation to meet an emission limit, then this piece of equipment no longer meets the definition of an inherent process equipment. All right, I'll take another pause. I see some activity. Thank you, Brian. Irana, you have your hand raised, or is this from last time?
Raised.
Yes, please go ahead.
Some processes where many people might consider a control equipment like a condenser, but all the solvents recovered are back into the process to be reused, and they have no other control. I wouldn't consider that control equipment in that case. But there are other in powder coating facilities in many of the places. They may have a bag house or some other fabric dry filter control. Then the particles collected are reused in the powder coating process, and they have nothing else. In that case, I do not consider these control equipment, but they are part of the process. Do you agree with it?
Right. So this is a conversation that would be had with the permitting authority and the applicant to assess whether or not this material recovery that is kind of cycled back, is that inherent process equipment or not. If it's integral to the process and the process would not function without it, would not function appropriately, then yes, it's inherent process equipment. If its intention or its use is to bring emissions below a certain threshold or comply with a particular air regulation, even though it may be used to recover material as well, but it's also capitalized upon like it's operated at a greater efficiency than normal to comply with that air regulation, then it does not meet the inherent process equipment. And that would be whether, like for that particular example that you shared, that would be a conversation between the permitting authority and the permit applicant to clearly define the control device in the equation or in the process and the inherent process equipment. All right. Irana, was that okay? Sounds good. Okay. We'll move along. Okay, so we're at the very, very end of our flowchart cycle and at the very last stop in the flowchart, but it's basically whether or not the pre-control emissions are greater than the major source threshold. So the CAM rule is based on a pollutant-specific emission unit. Now, before you put in the control device, are the emissions greater than the major source threshold? If they are, you've met the last requirement for CAM applicability, and therefore your emission unit is subject to CAM. If it's not, then you exited the cycle at the very last step, and your emission unit is not subject to CAM. So this is a very we spent a few minutes on the applicability flowchart to help assess whether or not an emission unit is subject to CAM. But briefly, it starts off with laying the foundation of what CAM is. It requires you to identify a pollutant-specific emission unit for a major source requiring an operating permit. You're required then to consider if that particular unit is subject to any exemption requirements. If it is, you're automatically not required to implement CAM. If it's not exempt, you would consider whether or not there's a control device in your train or in your processes. And then ultimately, before you have that control device, where the potential emissions greater than major source threshold. If so, you are subject to CAM. If you're not, then you're not. Before we move on, are there any overarching questions regarding the applicability of CAM or the flowchart? And this flowchart will be shared or will be part of the presentation. I see a hand raised, Carol.
So yeah, could you give an example of emission cap under 70.4 parent B parent 12? I have always had a hard time what would be a real world example of such an emissions cap?
Right. I hear you. The short answer is I do not have an example ready on me, and it is one of those nuanced exemptions that honestly I haven't come across yet, but I can definitely do a bit more research and get back to you regarding the cap exemptions.
Thanks.
And just give me a second. I'm taking down just a personal note. Alrighty. And thank you, Carol, for raising the question. Just a quick recap. We'll launch another pop quiz question. It should be in your chat. But it says, consider a new large pollutant-specific emission unit with a potential to emit a regulated air pollutant at 100 at or greater than 100% of the amount required to be a major source with an applicable control device. At what stage is the source first required to submit their CAM? Now, permits are long-standing documents. They are new. They are renewed over the year. The question is, at what point is CAM first considered? All right, answers are rolling in. All right. I think we can move along. And yes, most people have the appropriate response, and the first time you're required to consider CAM is as part of the application. It's a new permit, it's a new source, it's requiring an operating permit, and right then and there, you would consider you should consider CAM. A bit of trivia or a bonus element. What about other pollutant-specific emission units? And by other pollutant-specific emission units are those emission units where the potential to emit with a control device is less than 100%. So in the question, in pop quiz question 3, is with the control device, the regulated air pollutant is at or greater than 100% of the amount required for the threshold. Now, if it's an other pollutant-specific emission unit, that is to say, if the post-control emissions are less than 100% the threshold, then the first time you are required to consider CAM is not part of the initial application, rather it is part of the renewal process. So you would issue your first permit, and then when it's time to renew the operating permit, that's when you would consider CAM. All right. Unless there are other questions in terms of the applicability flowchart, we can move along. We just had the background, we discussed applicability, and at this stage, I'll hand it to my colleague, Brian, to take us through some implementation slides. Brian?
Thanks, Tasabala. All righty. So, implementation. Let's get right into it. Implementing CAM. So first and foremost, we need to identify and verify that the emission limit and standard is not exempt, and we do have an applicable control device for CAM in order to implement it. We need to recall that the general criteria for monitoring design found under 40 CFR 64.3 is to provide a reasonable assurance of compliance with emission limitations or standards for the anticipated range of operations at a pollutant-specific emissions unit. So, and we have some special criteria for the use of continuous emission, opacity, or predictive monitoring systems also included under 64.3D. But with regards to evaluation factors and indicators, we should consider taking into account site-specific factors, such as the applicability of existing monitoring equipment and design and the procedures involved there, the ability of the monitoring to account for process and control device operational variability, the reliability and latitude built into the control technology itself, and the level of actual emissions relative to the compliance limitation. And we also need to make sure that the measured parameters are properly acquired, that the instruments used are sensitive enough to identify potential excursions and exceedances or other changes in the control device behavior. Also make sure that the sampling location is appropriate and consistent with the permit terms, and that the frequency and averaging time of the data collected is on par with the emission limit set. So for example, a pound per hour limit shouldn't be monitored only once per day. And it's also important to have a quality analysis control on all of these factors, making sure that as time goes on, nothing slips through the cracks, and the monitoring established is continuous to provide accurate data and is updated as necessary. And this includes, calibrating your instruments, making sure that they are not degrading over time and providing inaccurate data, that maybe the control device is operating differently based on operational variability. So we need to maybe adjust the range and conditions for the indicators. Maybe the averaging time should be updated with regards to other changes in the process itself. So overall, it is a dynamic situation that should be looked at and accounted for when, planning on implementing the CAM rule. Looking further at the monitoring design and performance criteria, is there any existing monitoring to use as a baseline? Instead of reinventing the wheel, can we look at what's already there and use that instead of, giving us extra work to go through? Is there physical equipment design? What is the physical equipment design and operation of the control device? What can we actually measure that is relative to the emission limit or standard applicable here? Are the measured parameters directly related in ensuring compliance with the limit or not? With regards to the indicator range, are these supported by the most recent performance testing or other applicable data? What is it supported by to begin with? Is this, where are the values coming from? Are they related to a typical process, operation, and conditions, or something other? Is it sensitive enough, again, that changes in control device performance can be identified by the measuring instrument? Is the averaging period data reduction techniques, do the averaging period and data reduction techniques account for routine operating functions? And finally, we can also consider a potential threshold level within the monitoring design and performance criteria that triggers the requirement for a quality improvement plan, also known as a KIP, that will be discussed further on in the slide further on. So let's define first exceedance, excursion, and how to properly incorporate it into the permit itself. Generally, both exceedances and excursions should be defined as part of the performance criteria, how they will be reported, and how will the source respond to such situations. Will there be permit content requirement for these situations are found under 40 CFR 64.6 C2, and the response requirements are under 64.7D. But more specifically, the exceedance itself indicates that the emissions or opacity in certain cases are greater than the applicable limitation or standard. Whereas an excursion differentiates that it's a simple departure from the indicator range established for monitoring and not necessarily indicative of a violation of the emission limit. It could just mean that the control device is not working properly in terms of what its original operation was and might need some simple maintenance or fixing. Or maybe the operation has changed where the indicator range was not designed to account for that. And to incorporate this into the permit, the definitions are found under 64.6 C2, the reporting for 64.3 D3I and 64.9 A2I, and responses that should be included into the permit are under 64.7 D. Now, if a facility has their CAM plan approved, but they identify a failure to achieve compliance with an emission limitation or standard for which the approved monitoring did not provide an indication of an excursion or exceedance while providing valid data, or the results of compliance or performance testing documents a need to modify the existing indicator ranges or designated conditions, the owner or operator shall promptly notify the permitting authority and, if necessary, submit a proposed modification to their Part 70 or 71 permit to address these necessary monitoring changes. Moving along, we have the Quality Improvement Plan, also known as a KIP. So if information available shows that a source has not or is not using acceptable procedures in responding to exceedances or excursions, the administrator or permitting authority can determine to require the source to develop and implement a KIP. So based on the results of a determination made under 64.7D2, part of the CAM rule, the administrator permitting authority may require the owner operator to develop and implement the KIP with regards to a response to exceedances, that the determination of whether the owner or operator has used acceptable procedures in responding to an excursion or exceedance will be based on an information available, which may include, but is not limited to, the monitoring results, review of the operation and maintenance procedures and records, the inspection of the control devices, the associated capture system, and the process overall itself. Now it can, as mentioned earlier, it can be originally specified in the permit as an appropriate threshold, with an example being an accumulation of exceedances or excursions exceeding 5% duration of a pollutant-specific emission unit's operating time for a reporting period. The specific elements required for a KIP are under 64.8. And the implementation of the KIP doesn't excuse the source from compliance with any existing emission limit or standard or any existing monitoring, testing, reporting, or record-keeping requirements that it is subject to. So that is a brief overview of the implementation that you want for CAM once you've established CAM is applicable, you've established what the control devices are, you want to set the indicator ranges, the specific measurements and measuring tools and the measurements that are going to take. You want to have the quality assurance aspect to it. Now we have some examples to go through. For example, I should say, here's the CAM monitoring design example where you clearly have two control devices shown. You have a rotary zeolite concentrator and a regenerative thermal oxidizer. So just looking at the first control device, we have the mentions that it's going to monitor the desorption gas inlet temperature, so you have the location of the measurement, and ensure that it is not more than 15 degrees Fahrenheit below the temperature recorded during the most recent performance test. So it's based on the most recent performance test, and the value is listed there, 349 degrees Fahrenheit. And we also have a quality assurance aspect where it's calibrated and or replaced, the measuring tool, thermocouple here, a minimum of once every 12 months to ensure that the desorption is maintained at a temperature necessary to concentrate the VOCs from incoming airstream for delivery to the regenerative thermal oxidizer. We also have a pressure drop check for this control device where you are observing and recording that pressure drop across the concentrator a minimum of once every calendar quarter. So you have the reporting time there to ensure that the solvent-laden air may pass into the concentrator media as designed, and the control device operates as it should be. And finally, for that first control device, we also have the actual zeolite media observation, where an internal observation is being made of the adsorbent materials for contamination or erosion, a minimum of once every 18 months to ensure that that solvent-laden air may pass into the concentrator media as designed, unless tested within the prior 18 months. So we do have discrete values for the how often this should be done to make sure that this is continuously kept up with and that the control device doesn't degrade and its operation is maintained as it should be. Regarding the regenerative thermal oxidizer, second control device here, we have that also is monitoring the temperature, specifically the combustion chamber temperature, and we have a value there not more than 50 degrees Fahrenheit below the most recent performance test. Again, a reference to that most recent performance test with the value listed at 1,352 degrees Fahrenheit. And also the thermocouple is being calibrated and replaced a minimum of once every 12 months to ensure that it is in proper functioning. We also have the cold phase check, heat exchange, media transfer, media inspection there. An inlet outlet valve check, valve seals condition inspection. And yeah, basically it covers very thoroughly how to maintain this control device to make sure that the measuring devices that are measuring with regards to the indicator range that we have for CAM roll here are maintained as well, that any variability in the operations will be noticed and should be responded to as soon as possible, and that the indicator ranges indicator range values are based off of a most recent performance test, which should be indicative of proper compliance with the emission limit set. And I see there is a hand up. You can.
Yeah, so just looking at that, unless the temperature is required to be monitored at least once every 24 hours, I mean, that's what CAM requires, monitoring at least once every 24 hours, and I don't see anything in those monitoring examples that specify that.
I believe the data sample would probably be much more frequent than what is listed there. I'm sure that the measurements are probably continuous that are being taken from the thermocouple. So you would have a continuous stream of temperature being taken for the absorption gas inlet or the combustion chamber temperature for the regenerative thermal oxidizer. With regards to the indicator ranges here is what is, I think this is specifically showing is that these indicator ranges are for, based on the most recent performance test, and that, there's a limit, 15 degrees below for the rotary zeolite concentrator or 50 degrees for the thermal oxidizer. So and also the physical media inspections as well, just to make sure that the control device is operating and functioning properly. But there should be more in-depth monitoring with regards to how often the temperature is taken and averaged, which should probably be mentioned somewhere else within the CAM plan, and it's just not included in this example per se. All right, I think we can move on. We have another pop quiz question. If you want to prompt that up, this question basically asks, what is an appropriate monitoring frequency for a pollutant-specific emission unit with a post-control potential to emit greater than 100% of the major source threshold for an applicable regulated air pollutant and a pound per hour limit? I'm going to give it a few more seconds here. All right, I think we can end the polling here. So the correct answer is D, once every 15 minutes, specifically as applicable, and the permitting authority may approve a lower frequency. But under 64.3B4, we do have specifically in the CAM rule that the owner operator shall collect 4 or more data values equally spaced over each hour and average the values. That's applicable, of course. So D, once every 15 minutes, is the correct answer here, in part because of that rule citation. And as a bonus, for other pollutant-specific emission units, such as a PTU of post-control devices less than 100%, the frequency of data collection may be less, but the monitoring shall include some data collection for at least once every 24-hour period. Moving on, we have a Title V petition example where EPA objected to a Title V permit in part by some failure in the CAM section, and the particular specifics here are the justification of the CAM decisions within that permit record, with the first objection there being a failure to identify specific CAM requirements for the exemptions of flares 1 and 2. And this is for the Suncor refinery in Colorado. Some of you may have heard and followed in the news. So the first objection states that while the technical resource document describes the monitoring to assure the continuous presence of a pilot light, a continuous compliance determination method must also provide data either in units of the standard or correlated directly with the compliance limit, in addition to satisfying continuity requirements per its definition. However, the permit monitoring for flares 1 and 2 do not require that data be provided in the manner specified. One of the reasons why EPA objected to this. And the second one was a failure to require CAM for flare number 5. So while the Colorado Department of Public Health Environment acknowledged that the flare is used to control VOC emissions from some equipment to meet certain regulatory requirements, there is no discussion as to why it does not operate at a higher efficiency during the times it functions as a control device, with the condition 8.1 in that permit requiring Suncor to assume an efficiency of 98% at all times of flares present and 0% for every 15-minute block of time in which at least 1 minute was shown to not have a flame present. This requirement demonstrates that the flare is, in fact, at all times, primarily a control device and is required to operate at a high rate of control. And there's a link to the petition there. If once we send out this slide deck, you'll be able to look up if you haven't already. And I see there is a hand up, Irana. Question?
This question is about the flares. The flares, yes, they should have a pilot lamp to light the combustible fumes coming out. But there is another method some people are using, although they are not major sources, that this gas is almost negligible, and they're using once in a 5 seconds spark to burn the combustible gases if they are coming out. Do you consider, what is the frequency of the spark you think is equivalent to a pilot lamp?
Off the top of my head, I'm not sure. I would probably need to have a more technical information based on the process itself, what emissions how much emissions we're dealing with, what is applicable here in the case of what emission limits, regulations, and kind of go at it from there. But off the top of my head, I'm not quite sure the frequency. There are no other questions regarding this. I think we can move along. So we have coming to the end of our presentation. Some resources we have available for all of you to come look more further into the CAM rule and have some guidance and fact sheets is the US EPA's CAM webpage, where we have the Federal Register rule itself and the revisions listed. We have technical guidance documents. Specifically, we have a monitoring by control technique list, where we have a listing of the control device used, fabric filter. I think flares are on there as well as others, and how in the real world we can apply the CAM rule there. We can design the monitoring criteria. and all that. We also have a general fact sheet regarding the CAM rule and its implementation as well. As always, the Code of Federal Regulations, Title 40, Part 64 is where the CAM rule is codified. And finally, I would like to thank you for taking the time to listen and join us here today to learn more about CAM. For those that already know, might have served as a refresher for you. We will be sending out a feedback survey. There's a link included, but we also be including that as a individual, probably email as well. My contact and my colleague Hasbala's information is there. Also, I'm sure everyone wants to talk about CAM for a little bit longer. Unfortunately, this is the end. So, but we do, I think, have time a little bit for some questions that may have gone unanswered. See how Sabala's replying in the chat.
Thank you, Brian, for taking us home. Yeah, this concludes the training. However, if there are questions that haven't been addressed, excuse me, the chat rolls very quickly, especially when people type in answers. But yeah, you have our contact information. If you wish to reach out with any follow-up questions, we would happily get back to you. Or if there are questions you would like to take a few minutes and chat a little bit, please feel free to stick around. We'll hang out in the room for a little while, but this concludes the training. Thank you, everybody.
Thank you.
All right, I see the chat is buzzing. Where can I find the record? So the recording will be shared subsequently. We'll please stay tuned. I don't know if I can attach it to an email. I imagine we may share it on our website. However, in the meantime, we will follow up with you. We will share the slide deck, and in that you can have that momentarily until we get the recording ready. And in the email, we'll also share a link to the survey if you wish to let us know how Brian and I, or how your experience was today. Please give us that feedback. I'll scroll through the chat, try to see if there are any unanswered questions. In the meantime, please feel free to get off mute if you'd like to ask a question again, or in like vocally, I mean. So I see a question about SEMS and PEMS. So, and regarding the exemptions, so CAM stands independent. It doesn't matter. Like if the limits do have continuous compliance determination methods, they are exempt, regardless and independent of SEMS. Okay. Appropriate monitoring frequency, Brian said. So I see a question, Brian. I think you covered this. Would you like to address it? But it's regarding the monitoring frequency, and I think the confusion seems to be regarding the other pollutant. And maybe share the definition of other pollutant one more time. Other pollutant specific.
Let me scroll down and see. Appropriate monitoring frequency. Yes, I think that was for the other pollutant. So if you are above 100% of the major source threshold, then it would be, once every 15 minutes as applicable, with the permitting authority being able to approve a lower frequency, with the once per 24 hours being for if you're less than 100% post-control device PTE. I think the distinction there is whether you're above 100% of the threshold post-control or below. Yes, Norm?
Is my audio working, first of all? A lot of times it isn't.
Yes, I can hear you.
Okay, good. All right. So my question is revolving because early on you gave an example of saying, okay, if some unit has a pound per hour limits, then monitoring only once per day wouldn't be appropriate because it has a pound per hour limit. But if that is an other, so if the post control are less than major, so it is an other pollutant specific emission unit, CAM only requires at least once per day. So would that possibly be an appropriate monitoring frequency, even if it has a pound per hour limit?
In that case, I would probably side with no, because it should be relevant to the limit. And if the limit is in pounds per hour, and you're only measuring it once per day, then you would be potentially missing out on the 23 hours of potential events where there would be non-compliance with that pound per hour limit. So I think it depends basically on what the limit is and whether the monitoring is connected to that limit. If that makes sense.
Okay. Yeah. Thanks.
Brian, if I may interject a little bit.
Yeah.
So yes, Norm, I agree with the above, and I just want to point out that in that particular case for other, it doesn't require a collection of once per 24 hour. The regulation, which is in 64.3b4, it says it may be
Right.
Once per 24 hour, and then again, it's if it's applicable. So it is case by case, and it may be so, and it may not be so.
All right. Well, it's just it has to be at least once per 24 hours. That's what the CAM rule states. If it's another PSEU, then at least one indicator has to be monitored at least once every 24 hours. That's what the actual rule states. But I was just wondering if, because it's another, we could go with once per 24 hours, or if we would be sort of required to go more frequently if it's subject to a pound per hour limit. That's really my question. All right. Thanks.
Thank you, Norm. All right. Brian, how do you feel? I think we went a little bit over time. Should we conclude the event? And I see some people are in and out of the room, but we definitely lost.
I'm trying to see if there are any questions I can answer off the top of my head. Are any Region 5 states issuing violations for failure to meet? I'm not quite sure. As a permitting section, we don't issue violations, so that's something I would contact the Region 5 enforcement staff about in particular. Let's see, anything else? Are low NOx burners a passive control device? I don't think they're considered maybe a passive control device, but they're also, I think, excluded from the definition of control device, as they are typically already part of the equipment. Like, I don't think you can buy a boiler and add on the low NOx burner after it. It's already comes with it. So I don't think
it's inherent.
Yeah, I don't think it would count as an add-on control device there. Fabric filter, generally a fabric filter is a control device, unless you can there's other information going on there regarding the process itself. Maybe one more question, Masambala, anything you see?
No, Norm, was that a new question, or was that like the previous comment on the frequency? Oh, okay.
Yeah.
Thank you.
Yeah, sorry, I didn't know I had to lower my hand.
No worries.
Makes sense,
no
though.
worries. All right, folks. I'll keep the slide on our contact information. And Brian, did you find anything we could address, or should we conclude the training?
I'm scrolling, but I'm not seeing anything immediately I can
I'm hitting
Provide.
answers, like when people respond to the poll. Okay. Well, apart from the one question that we said we'd get back to you, if there are any other questions that pop up, please feel free to reach out to myself or Brian. We will share the slide deck with everybody. Please, if you have the time, should take you 5 minutes, do the feedback survey. Let us know how we did. We do appreciate the feedback. And yeah, thank you everybody and have a wonderful day.
Thank you.